All right, welcome to my talk, Managing APIs in Enterprise Systems. My name is Pete Muldoon, and I work in Bloomberg as a senior software engineer. And what we're going to look at today is using APIs in large applications, and I'm going to use a case study of work I did approximately a year ago. I would have probably given this talk earlier, except for the pandemic. All right, so one thing I want to say is if you can take a note of a slide number if you have a question. I will pause at certain spots to say, give me questions. And if you can just give me the number, it's easy to navigate back instead of saying it's like something you were talking about, 5 minutes ago. All right, so in this talk, where will we be going? What are we going to do with this talk? So this talk will be about using APIs in an application system. Right, so what this means is we're not talking about designing APIs, even though this talk has me under API design as a track. This is about using APIs given to you. This talk is, as I say, based on a real-world enterprise system that was being rewrote from scratch. It has coroutines, there's a lot of parallelism, and a lot of good engineering practices. We're going to focus on a slice that I was working on, like I say, about last year. So there were early design decisions that were made. Some I agreed with, some I wasn't so happy about. But I will attempt to justify these because I need to set the table to see where we're going, right? So I have to set up where the project was. Other paths undoubtedly could have been used, or other ideas. Are they better or not? Well, that's something we will figure out right through the debate. But the main focus for this talk is going to be handling change. And that's handling change in a system where the outcome being wrong has bad consequences, right? In this case, it was a large trading system. So if we get things wrong, money goes the wrong way, and we have, reputational damage. We can be actually, I think, sued for this kind of thing. So enterprise systems, we use many APIs, right? We have APIs for database. If you want fast memory access, you'll have a cache, IPC functionality. And these provide you with essentially reference information. In this case, with a trading system, you get a client ID. You want to know what his permissions are. So you go someplace to a service and you say, give me all the data to do with that. He was trading a particular security. Give me all the data to do with that. So it's all kind of referential information that is not included in the requests you get. You also need persistence because the state of the system or where this transaction is at is very important. And if you fall over, you have to be able to recover. All right, take a seat, guys. And then the side effects get propagated out of this system. And like I said, these can go to some other place in Bloomberg, another system someplace, or they can actually go out down into clearing, all these kind of things. So APIs. When I go to put a talk together, I always go and see what's out there to see, has anyone covered this topic? Am I just going over old ground? So when I went and did a search for APIs, just a general search for talks, not tutorials, there's many tutorials on writing APIs, this is what I found. And most of this is about designing a good API, right? Which is important, and as you see, can take quite a long time. So there's a 2-day training course given by Bob Stigall on it. So these things there's a lot of stuff to try and figure out. So I'm going to say that what is good API design? I can only give you a few bullet points, but this is what I look for as a user of an API. It's got general use and it's flexible, meaning that my use cases are probably handled somewhere in there. It usually will have many available modes of operation. That's something I really won't want, but a commercial API will want to satisfy a large audience and be very functional. Testability. In this day and age, I hope we've got it into our heads that we need to be able to do dependency injection, do mocks, and be able to test out our system and not test it in production. And then ergonomics, right? So it's relatively easy to use. It's got good documentation. What about the good use of APIs, all right, which is where this talk is sort of heading? Well, if I'm a user of an API, I generally want a specific use case. I want my specific outcomes handled in the way I'd like them done. I have constrained modes of operation because I do not want APIs used in very surprising ways. In my code, I look at them and I say, I wonder what this guy is doing. And then we use them also code efficiency. So this is various boilerplate we always do before we access an API. But we generally do not use raw APIs. In any system I've been in, if we're writing to a database, there's some kind of database class, whether it's Sybase, Oracle, Cassandra. We always wrap these things in some kind of abstraction so we can use them for our use case. The thing to note about this is that if you look at the API designers sort of table of bullet points up there, and you look at me as a user, so I'm on the consumer side of this, the first 2 points kind of go the opposite way. Right? As an API, I want something very general, but as a user of an API, I want something very specific. Right? So I thought that was interesting. I didn't even realize this till I wrote this down when I was putting this talk together. And in some cases, you will actually write your own API for the system, and that will generally be a very constrained API. But if you use an external APIs, you don't really have that freedom. So how do we translate from the top to the bottom? We usually have some kind of wrapper abstraction, which constrains it to the way I envision my system wanting to use a particular API. So if I look at a very, very simple diagram of the system we're going to be talking about, it's a financial transactional system. I have users sending in actions that they want performed. And like I say, I go out to various services or databases or wherever for sources of information to flesh out that request. I will do my operations. I will save this in a database. In this case, it was Cassandra. And then these effects will propagate outwards, right? So if I make a trade, someone's got to know that someone traded with them. But like I say, most systems are in a pipeline. So this was my system, but it fed right into another one. And this is generally what we have happen. You're generally not a universe of the whole system goes through you. There's many systems in a chain. So if I go back to my system, what I'm going to want to do is, for my purposes, I'm going to say, I'm going to study what the effects were. These were the important byproducts of doing transactions. Who's going to pay who what? What are they going to trade? So let me get rid of everything else. So here's what we're going to take as a slice of the system to show about how to constrain APIs and then how to use those constraints to help us when change happens. So I have an external API, and in Bloomberg I've changed names to make them a little more comprehensible, but we have a comms API. And what that comms API does is it says you can there is lots of modes of operation on this thing. It can do things like send one way with ACK because you don't need a response, encode it into XML, bear, JSON. Use blobs, use structured data. There's all kinds of width to this API. The one thing to notice is the ones that are most commonly used is the blocking, where you send a request and you get a response back. So you wait for whatever external system to service that request. Or you can do an asynchronous version. And in the asynchronous version, they take a callback object, and that callback object has to have a particular signature, and they pass you back an allocated piece of memory that's under their version of a unique pointer. Because this is an older API, so they did not have the standard unique pointer when they built this thing. But they have a version of it. All right, so here I am. I have this really wide API, and I want to constrain it for my system use. So the first thing I did was say, well, they were on a good thing, I think, when they had the type name for request response. And remember, this is not just going to be used in the slice we are looking at. This is used wherever my system needs to do any kind of request of data from a server, right, from another service. So I start off with this response send in a request, get a response back. So one of the design decisions that was made in this system, and I actually like it, was that we wanted to take hold of the response object and limit its ability to be copied around the system, because these could be very large. So what we did is we say, okay, we're going to have another construct called a response carrier. Now, the request and response are not something I'm writing. They're generated elsewhere, and I have no way to constrain how they work. So how would I the decision was to make these things move only. Who here can tell me how I can make the response move only?
You can just rule 5, delete the copy constructors, default the move and destructor.
Okay, so he said to delete the copy constructors, write move constructors. That's one way to do it. So that gets it.
There are simpler ways.
And I think I have a simpler way. Okay, anyone else? So that's removing those. What do I do with the memory that's been given to me? I take the raw pointer and I manage it. And that way now I say, so the response is in there, I'll manage the memory management. I think that's a terrible idea.
You can wrap the memory in a unique pointer, and because it has a member that's not movable, or
That's exactly the solution, right? He said, why bother with trying to do your own memory management, figure out ownership, have people say, what does your class do? Wrap it in a unique pointer. And if you wrap it in a unique pointer, it's already had its copy constructors deleted. So you can't, because it's a member of this class, it makes it move only. So then my service becomes a response carrier of this thing. I now have control of the copying of this. All right? One other thing is I do not want blocking calls in my system. As I said, this system actually had its own coroutine library. It was started to be wrote, I think, in about 2013 in C++11. There wasn't even boost fibers back then, so they decided to write their own coroutine library. So ultra lightweight threads of execution. You can have 50,000 of these execution threads in your system, and you're still okay. If you try to put 50,000 threads, you'll probably blow up. So how do we make this call into a non-blocking call? Anyone? Callback, and that's what the underlying system does. Future, all right, that's what I wanted to see, right? So we have this idea that using callbacks and all of this thing, we've gotten into trouble before. It's hard to do right, so what we say is, look, we have future promise semantics now. All right, so this turns out to be, there is some constructor piece here where we say what service we're actually connecting to, but for slideware, and it's uninteresting in what we're doing. So this is what we go with as my wrapper for talking to any external service. So in my application, I'm going to use this now. I've got a nice constrained API. I got my service. I'm going to call it service A. And all I have to say is service A is just my service with a request and response A in it. Right? Simple. In my main, I say, look, create me one of these things because I'm going to guarantee the lifetime of this object and it doesn't hold any state. For my error handling, this is something I did have some words with the original authors because they wanted to use exceptions in this way. And I said the paradigm for exceptions is if there's a problem, I throw, and that will work its way up, get caught, go back to the user as an error response. And if it does nothing, it means I'm successful. All right, so this is the paradigm they used. Like I say, I'm not a huge fan of it, but it worked well. And if it turned out to be a problem in the system, which I ended up using Cybrands on std expected to replace this, but that's not part of this talk. So everything on the left here is, let's say, single file. I have a single service A.h file, single main CPP, error handling, it's a single file. On the right, I now have my action handler. So users send in various actions. I want to create, I want to correct, I want to do this, I want to do that. And we have many action handlers. I'm just taking a general one. I'm going to call it ActionX handler. But there's hundreds of these things, right? And inside of this, I'm going to put a service A, so I can talk to the external service. And I have an execute. So when an action comes in, I make a request, because that's how I talk through my service. And there is a bunch of logic and a bunch of getting referential data. And all of this stuff goes on that eventually packs this request. And once this request is packed, we say send it and give me the future back. All right. Now I want to get the result out of that future, so I got to call .get. If the promises has been set with a value or an exception, we'll get it, or we'll throw out, which works with the whole check response.
Are you now synchronous again? Are you now synchronous again?
No, I'm not, because what happens is when I hit this get, right, the whole coroutine is paused and we go and we take another request.
So there's no call, no call wait.
right? It's not co-await because it's not the,
Not the standard Bible.
okay,
It's
so
a stackful coroutine, right?
yes, so
Stack switching.
the question was, have we not just come back to be synchronous because we have a send with a future and then we immediately ask this future for its result? So you could look at that as being synchronous. This is the sort of kind of slideware. So in reality, we fan out, right, to a lot of different requests and we pull them back in one spot so they get done in parallel. But this works. Like I say, we have coroutines that we wrote ourselves in this system. So if you do a get, it just goes on as sort of essentially a queue of coroutines waiting for their promise to be satisfied. And then we do the check response. And if you remember, I've got an auto pointer, not an auto pointer. I've got a unique pointer inside of my carrier, and I'm just going to say dereference that result. So that goes as a response A, const response A, and if it checks out, we're good. We can continue on and just return. Otherwise, we'll throw an exception. We'll generate an error back to the user. All right. Any questions so far on this? All right. So testing, like I say, if you're, this was a great opportunity to work in, like I say, a brand new system being wrote from scratch. And it's very difficult to make those successful, and these guys have made it a success, but they had a lot of testing. So how do we do testing? I hope people are familiar with the Google mock, because that's what we use. So what we do here is we say, listen, I'm going to inherit of whatever the base class will be, which will be a service A, a service B, a service C, whatever. And I'm going to give it the call, right, that says, hey, when you give me your request, return me a future with the response in the carrier. And then I'm just going to say, here's my mock method, so the calling function that's doing the test can satisfy this call. And all this does is say, listen, I'm going to have an onsend function, and its signature is take a request and return a pointer to a future carrier. The reason it's done like that is the unique pointer makes it a bit awkward if you don't want to allocate memory, and we don't. So because I now have a mock, and as you see, I inherited from it, okay, I need to be able to drop mocks into all these handlers to be the mock service. What that means is I need dynamic dispatch. So everybody hold their breath, right? I have to make this virtual. Now, I don't really have to make it virtual. This is just the easiest way to do it. There are tricks for static polymorphism. If someone wants to come after class, I can talk about them, or after the talk. But really, this is the easiest way to do it, and that's what we did. And if we had a performance penalty, we would come back and change that. But we don't want to over-optimize before we find a problem. So the testing itself, remember I now have an action handler. So I'm going to make a fixture. This is it on the right. And as you see, I initiate the ActionX handler with a mock service instead of my own service. And then I just give an execute function to keep the boilerplate out of the actual test functions. So remember, when you're doing this type of test and you put some input in, there's two outputs really of this thing, right? There is a response that comes back, and you get to see that, but there's a request that goes out, and that's hidden, and that's where you need dependency injection. So really what you want to be able to do, the more interesting thing to look at this is the request that's been sent out, not the response that comes back, because you're generating that response in your mock. All right, so we've done the fixture. Now I want to do a test. So I do some setup, just so I have some kind of action. This will be a bad action that's going to cause me an exception. And I'm going to have a response. This is just, I don't care about the response. It's just something to satisfy. But if you see the first line there in green, you say, I'm going to expect a call to my service. And once I get that, I'm going to save the argument, which will be the request generated inside this handler. All the data permutation, all the stuff we can't see is going to be put in that request. And I'm going to save it to the request, the local request at the top. So then I can examine this. All right, so I can look inside what the handler is doing. This is what I will call the unhappy path. So we execute this action on the handler, and it's going to throw. We make sure we get a runtime error. Right. We could also look at the request. If make sure the request has something in it that we expect it to go out. The happy path, which is where we always want to be, where we don't have exceptions being thrown, I'll do the same expect for a call, and then I expect no throw on the executing of the action by the handler. And then I can say, okay, you know what, start examining the request to make sure that it was put together correctly, because I control the action going in the testing. And then they also have, I'll just mention it briefly, a way to do the white box testing. So to reach in to where the state machines and stuff live and see that the order was created properly, right? Because that's really very important in the game that we're doing here. So this goes into production, and more and more clients get moved over. There's more and more mitigation of risk needed, because if you take that new system out now, there's thousands of customers that are going to be affected, right? But time goes by as we're making more and more variety in the action handlers. We're bringing new customers on board, so everything's nice. But change is in the air. All right. So, in other words, you very rarely have a static situation going on. New requirements, new business needs. So we get a requirements change. All right. And this is deemed like very high up important, because we're going to replace service A by service B. And what that's going to give us is a whole load of goodies if we do this. It's more direct. There's better throughput, better latency, and we have less points of failure, because we're actually going to go direct to a source. However, the new service is being built out. This new service is not actually new, but our connection to it is going to be new. So they have to do a little work on their side. We now have to worry about risk in the system. If I take this system down, there will be hell to pay. So what do? Well, looking at our slices system from before, we have this request response. We're going to put in a service B that's going to do our effects a lot quicker, faster, and we're going to eliminate service area. And this is where we want to be at the end of what we're doing. So, any questions so far? I'll continue. So here's what I have. We've seen this before. What I can do for a straight swap is, now you got to watch this carefully because these things change, is service A. Well, I'll write a check response for the new response. It's got different fields. It's completely different. But I'm going to just change service B to be a service with these requests. Change my instance from service to service B. In my handler, if you look down here, watch it, I'll just change this to service B. We're done. Right? I've absorbed a huge amount of change very quickly. Well, yeah, then I decommission A, right? I get rid of the check response because it's nowhere in the system anymore. Are we done?
We're going to fall back to A. Lights out.
All right, so someone made a comment, what happens if B has a problem? Can we fall back to A? Not doing this, right? This approach is really risky and generally won't be tolerated in the environment I work in, right? The new service may be unproven. And in my case, it was somewhat unproven. But maybe it's a very well-established service you're connecting to, right? But what I do know is your interactions of your system with service B are definitely unproven because you've never done it. And even if it seems simple, it probably won't be. So straight swap is out. I don't have that. I mean, if you're doing something, I guess, where the results don't matter so much, you know, you can like take a second shot at it. This is a way to go, but not in a fault intolerant environment. So what we really want to do, as was pointed out in the audience, is what we really want to do is say, let me add in service B. And in the beginning, there's very little to no traffic going through it. Most of all my important customers are being routed through service A. When I get more confidence that the smaller clients are not being hosed, I can then direct more and more and more traffic over to service B and eventually just decommission A when nothing is going through it. And this is the kind of viewpoint or what I want to keep in mind, that we want to get to the decommissioning state, because what we do not want to do, and we're going to see it now in a minute, is make the decommissioning equally as risky as the change itself. So when I try and decommission this system, I bring the system down. So what am I going to do? Well, what I have seen in quite a few places, and I don't mean Bloomberg, I've been doing this for 30-something years, and as a consultancy in lots and lots of different spots. So what people will do is say, look, let me just have a service B here. Okay, I'll create the service B. I'll leave service A around because we're still going to use it. I add a new, I have the error handling for response B. And in my handlers, what I'll do is I'll say, add a service B in there. And then just say, look, I have some route function that will load up a configuration or check a table somewhere and say, if it's these clients, check the request, and if they match, route them through the new service. Otherwise, route them through the old service. It's not that interesting. It's just a way that we can control which clients are going where. And we'll take the lower volume, less, I won't say less important clients, because everyone's important. But you know what I mean, right? So we have a problem here. What is the problem? Anyone?
Repetition.
That's right. I have hundreds of these things in my system. So what I am doing is adding new semantics, routing, new members everywhere. Now, you might think this is kind of like a month operation to do this phasing over. It will be a year, 2 years, and I'll get back to what happened in my case. But this takes a long time. And you can be guaranteed if you leave code like this in a lot of different handlers for a long time, people will start going and doing stuff in each branch so that when you try to decommission it, it's now a risk nightmare. Right, you have to figure out, oh, well, now that we're routing through the other thing and I have special things going on in the service A side, do I need to mirror them? Which is more correct? Right, these are all problems I've faced. So brute force is out.
Do you also have a performance degradation? Is the if a runtime check?
It is. The question is, do we have a performance degradation? It is a runtime check, but it's really quick. Right? We load this thing up, the list of people who are going to go through the request B, and it's just a simple comparison, I think, of like unsigned ints. So it certainly wasn't a problem for us. All right. So like I said, brute force is out. So what happens if I start thinking a little differently and say, what about the migration path? If I think of this thing as not just how do I get service B up and running, but how do I allow for the decommissioning of that in a way that doesn't give you risk? So I always like to say, let me get myself a few requirements so I just don't go off into very strange places, right? So what are my requirements? So I'm going to say I want to localize meaningful changes. What that means is all the code that's handling the actual who gets what comes back is in one spot, not hundreds of spots like the brute force approach. So everything that's actually handling the change is in one spot, and it'll probably be a new file. All right. I want to keep the global usage the same. That means that every place that's calling my code does not have to change how it's doing its operations. Now, I say semantics there because you can, and I'll highlight it as we go through the slides, what you can do is say, look, I'll change the implementation of meaning and don't change any names or type names. Horrible idea, right? I was on a project where I looked at something and inside was called the database. And I found that it actually sent messages over the MQ because they used to have a database that they used for transferring information. And when they changed it, they didn't rename the type or the name of the actual variable. So that's bad practice. So the types names may change. The variable names may change, and they actually will. But a good IDE will handle this because none of the calling semantics will change. I won't ask any different, well, there'll be one slight spot I'll show where I actually did. But for the most part, I'm trying to say my contract with the calling functions is unchanged. And this means I will not have sweeping changes throughout my code base. And this is important because this means the rest of your code base remains untouched. But you do have to work at it. And it also means that you don't have throwaway work, like taking all these ifs back out, removing the members. And the decommissioning is simple. It's really simple and very low risk, and I'll show you that later. One thing I found when I did this is I thought, hey, I'm ready to go. I've kept all this and we'll see it later, is that we had to watch out for unit testing because there is a large amount of code. And as it turned out, I think there were 4,600 unit tests. And when you built the unit test, that executable was bigger than the actual task that we ran in production. In fact, it was getting so big, we had to figure out a way of splitting it. All right, but it's a large amount of code. And remember, in production code, you have to be very careful and follow best practices. But in testing code, you're allowed to get tricky, do backdoors to get to look at stuff, right? So that can be challenging. And mocks may, I'll tell you, they actually will always have different semantics. So how do I prioritize the migration path here? So what I want to do is on my left-hand side, which remember is single points in the code, I'm going to say, look, instead of a service A, I want a service proxy. What that has in it, I don't know yet. I'm also going to have the response that comes off that is going to be different. There's no way it can be the same. It's going to have either a response A, a response B in it. So I'm going to need something that's able to check which of these is actually correct, and if it's not correct, throw. So this happens on one side, which is fine. On the other side here is where I have the hundreds and hundreds of handlers. How am I going to handle that? Well, what I did is I just renamed the member to proxy. It actually makes it look good in the slides too, because if I don't rename anything, there's nothing to show. And then down here, I just say proxy.send. I have changed none of the calling semantics, none of the usage semantics, right? Everybody has to, it will just work if I can fulfill the contract I have with all my users. And that's another reason why you have an abstraction, so you can absorb change. So now I have to write a proxy class. What do I need in here?
Send.
Yeah, but before we get to send, what am I going to send on?
Service A and service B.
That's right. All right, people said we need a service A, service B. Obviously, because I'm going to use one of them. All right. And as someone pointed out, we need a send. And here I have my routing request in one spot. One piece of code is going to do the routing. And it's going to stay like this. If I see a code review that tries to mess with this, there's going to have to be a very good reason. And always I'm going to say, look, when you send a request with service A, wrap it in a var_resp future, and service B, put it in a var_resp future. So what is this var_resp future? It's a variant. And what has that variant got inside of it? Well, what does A give you back? A future.
Response A.
That's right. So we just have the carrier for A and B in there. Simple. You're like, wow, this is elegant. And I say, let it rip. I put this in. And the other good thing about having a proxy is that I can take one of the handlers and make sure it works instead of going and having all hell break loose. So I say, let me compile and try and see if this works. And I get this error. No member named get in std variant. And there is no member named get. There's an std get, but that's a different talk. So if I go back and look, here's where I am in my global calling contract. Right? I used to get back a future, and with that future, I resolved it to an actual value with the get. So now I'm returning a variant, and variant won't do that for me. So I have to say, listen, taking my var_resp future, I got to wrap it in something else to fulfill this new contract, right? So what do I need? I need something like this. I have a get function here, and what this get function does is take, whether it's a future of service A or a future of service B, it resolves it to the proper value, which is the same meaning and semantics we had before. So this should not be surprising. Right. And again, what is a var_resp? Anyone?
Variant between the response A and the response B.
That's right. Right. So look, so I think it's easy to reason, right? People are answering this in the audience. So people knew this was going to be a variant of service A, carrier service B. So I say, okay, this is great. Let it rip. As you see, now I can say, I compressed it, right, because I don't want many lines here. But as you see, I can send it now. It gives me back a variant of futures. And when I do get, it gives me the variant of actual values. If anyone's interested, overload is just a neat little trick. I think this is probably similar to what's on CPP preference, except for I have a deduction guide that says move stuff instead of copy it. Because we were very move intense, as you can see. Right? All this does is takes a bunch of lambdas, and if you call it, it picks the inherited lambda operation. So now I'm in my service proxy, and I say, look, when I do a send, return me this result future. Are we done? Right? Because now I don't have a res pointer, which is this member inside of my response carrier. And this was, so when I seen this first, I'm like, ugh, this is ugly. And if you remember, here it is here. Right, so what we used to do is say, look, go into result, find the member res pointer, which is unique pointer, dereference it, and we'll do result. This turns out to make things very nasty for me. If I go back to my result here, and I want to satisfy this contract, what I've got to do is say, put my variant inside of it. I need a member res pointer, so I set it equal to this. It's useless. No one really likes this. And then I say, when you dereference it, give me back my variant. Does anyone like this? All right, I have no takers. Right, this is ugly.
It's okay.
No, this is not okay. Someone said this is okay. I'll talk with him afterwards. This is ugly. Do not do this. Right, if I go back to my response carrier, this is the root of the problem here. And what I really should have done is say, give me a member function to access it. Because that gives meaning to what I'm doing, right? And makes it, you're not messing with the internals. And if some reason down the road I had to change the unique pointer, I can absorb it in this function, right? So what I did, now this is where there's a small wrinkle where I changed things. I don't think I changed the semantics, but I changed what was going on. I opened a new PR, and I said, the only change I'm doing is this, changing to a get response. And that meant that this result here, instead of doing this, looks like this, nice and tidy. Question?
Yeah, so we're executing different behaviors based on different types, right? So in my brain, I like naturally default to thinking about spin A, and I was wondering if you thought about implementing this with that, or like if that's even possible. I guess concepts in 23.
So you could have a concept on maybe this here, what is a response? I don't know exactly what the concept would be, other than maybe it's serializable or something.
You could give like a tag to your service that you want to deprecate in your service.
So the question is, could I not have done concepts and spinny? And the answer was no, because that's much too hard for me. I'm a simple man. And when I try and find problems, I want them to be simple problems. And I only use this stuff where I actually have to. So if there's a simpler way, I'll take it.
You're also only going to know which type of response you got at runtime. And so turning that back into a compile time dispatch that concepts or CNA would be associated with seems like probably unnecessary.
Okay, so let me just summarize that. So someone in the audience says, listen, this wouldn't be a compile time thing anyhow, because we're dealing with runtime decisions of what comes back. In actual fact, you could have essentially a switch table, right?
Sure, yeah.
Which would get you from that runtime to compile time when you jump into the table. But these are all sort of hairy things to do. And remember, I have a running production system, and doing hairy things is what I want to stay away from. Yes?
You could do it, right? Because the handlers are the ones that are deciding which request and response they want to be dealing with, right?
No. No. The proxy's deciding that.
But in the original, the proxy is now.
Right.
But in the original one, so it's like you would have to, if you owned a handler, right, you would decide which one you would use, and you would compile it against the new library that had.
So the question is in the beginning. So what you're really saying to me, and I'm going to translate a little differently is, in the beginning, couldn't you have foreseen this change
No.
and put systems in place for it? No, that would be pre-optimizing.
I'm not-
Maybe I never change.
I'm not trying to be difficult. I am just curious if this was a viable alternative approach.
We did not think of it. I don't think it's that viable, but I'm happy to discuss it after the talk. All right? And even run it up. I will have a bunch of God bolts at the end of this, so we can go into God bolt and run this thing through, right? But like I said, getting back to, I've almost forgotten where I was. Oh yeah, so here we are. So now what happens is, right, we can say check response, result that get response. So as I said, I opened a PR for hundreds of files, and the only thing I changed was, and I used a decent IDE, was instead of dereferencing that res pointer, is to change it to get response. And when I put that PR, people are like, this is a boring PR. It's the same thing in 100 files. You're just doing the one thing. And that's another way of getting large scale changes through. If you keep it simple and people get it in their head, it went through without too much issue, right? So now what happens is in my handlers, this is what I have. And I think this is more expressive, which I'm always a fan of expressing. So check response says, hey, go get the response from the result. I think this reads better. All right. So what about result analysis? So that takes care of sending stuff in. What about the examination of what comes back? Because it's different. It's a different type, right? So in my error handling CPP, the one file that handles my errors so far, I have a check response for response A. Response B is completely different. So there's a bunch of different checks, but it will throw an exception. But I'm not getting response A or B now. I'm getting a variant of response A and B. Well, that's easily handled with my old friend overload. What I say is, listen, when you give me this proxy response, I'm just going to say if you have a service A carrier, check it for service A with that overload. Otherwise, check it with service B. And I think this keeps the same meaning. In other words, I haven't sort of deranged off into some like really theoretical argument about how it could look this particular way, and you know, it sounds crazy, but it actually isn't. This is just clean, easy to worry about. Question?
Couldn't you technically do this instead of having an overload with two separate lambdas? Couldn't you do a just a generic lambda const auto response and then just check response for either? You lose a little bit of type info, but it's a little shorter.
So the question is, could I use a generic lambda instead of this? Quite possibly. I would have to think a little about it and sort of mock it up to see how it goes. But that is some way of doing it. But this is what I've been using. It's very straightforward, and I would say not surprising for people, right? And certainly the guys knew about the overloaded in our system, so it was easy for them to get a handle on it. So this is going to check off my result analysis. Boom, great. So testing. So this is what I had before, if you remember, all right, where I have the send, and that's just forwarded it to mock const method where the calling function can determine what comes back. In my mock service proxy, how is it going to look? It actually is simpler looking. All right, all I'm going to do is say, listen, you have the same kind of send function, and I'm just going to have a const method that looks pretty similar to the one above, except instead of returning a bare future, it's going to return this result future, which remembers the variant of futures inside of it. Straightforward, all right? I want to do testing. This is what I call the uninteresting test, right? So I just check that the mock service works on its own instead of in handlers. You know, hey, I'm going to send it, and then I'm going to see if we throw a response. These are uninteresting, and these are just checking the base functionality of the proxy itself. The much more interesting stuff is the handler, all right? So right now I have a service A in there, and in my test fixture, I'm going to put the mock service in. So what changes do I do in my, and believe me, there are tons of tests. I mean, you take the file count, multiply it by, I don't know, 40 or 50, because you're not allowed to put a code review into the system without or a code change into the system without an accompanying test for it, all right? Which is, you try and give them, even if it's the cleverest code ever, they'll chuck it back and say, I didn't see a test in there. Come back to me later. It's not wasting my time. So what's the changes? Look here, it's going to be subtle. I just changed the proxy up here. Any good IDE will handle this. This is not something I have to worry about. I could be unscrupulous and leave the names the same and just hide the implementation under the same name. That's bad practice. And as you see, it just becomes a proxy.send. Down in the fixture, you see we have a mock service proxy now instead of a mock service or a mock proxy. And we just initialize the handler with the proxy. Question?
I just want to confirm all of these changes we are making are to code that is internal, not exposed to users anywhere. Is that correct?
Right. It's inside my enterprise application space, which is a lot of code. It's big. It's meant to. It's one of the largest transaction handling systems we have. But yes, if I was in some way constrained because some external groups were using this, then I would have to keep the things the same. But this wasn't a constraint here. But as you see, there's very little change going on inside of the mocking, right? I've changed some types, I've changed some names, but the actual calling code is exactly the same. So I don't have to do very much. And if I put a PR in for this, people say like, hundreds of files for the same thing and it's boring. And I have to say, here's the 4 files you need to look at, and you can sample the rest of them. Any questions so far? I know it seems ridiculously easy, right? I don't see it done this way a lot. So we're going to go and look at the unhappy path. All right, so what do I do here? This is the original. This is the original. Watch it very closely. That's the only change that gets done. And again, any IDE with a refactor function will do that. It's not even the interesting piece of the function, right? This is just saying, hey, the response that you're going to return as part of your expect is going to be something else, but I still capture the request as it's going out. All right, here I throw. I look at my happy path. Again, here's what we had before, where we're saying, hey, you know, we don't expect to throw on this one. We can examine the request as much as we want, and then we can also reach in and look at all the state that's in the system to make sure it's correct as well. So what do we have to change for this thing here? That's it. This is the uninteresting parts, what I call. Right, all as we did, if you missed it, wrong way. If you missed it, we have a service A response being given back by our build response. And we have a service. Now, I just renamed it to build a proxy response and return a proxy. That's it. Again, very clean. And if the code that was originally written, and like I say, this was a new system, even though when I talked to the manager over this, I said, is this a brand new system? He said, yes, it is. So how long has it been in production? 5 years. I say it's a legacy system. It's just a legacy clock went on it when you first became important enough to be noticed, right? And over time, you'll migrate more and more into the legacy space. But hopefully, your practice like this will insulate you somewhat from change. Now, let's go to reality check. So everyone's saying, hey, there's bunches of different ways. When I gave a dry run of this talk, people came up with a lot of different solutions for this thing. But here's the thing where reality bites. So in effect, a request A was a vector. We'll call it request B, not exactly, but it was a vector of requests. So this thing that I sent to originally took a bundle of requests, got answers, and sent them back, right? But, so you see there, it has a vector of requests going out, and it gets a vector of responses coming back, right? When I move to my new service, it does not handle groups of requests. It only handles single requests, right? And it not only handles single requests, there's a lot of processes so it can be done in parallel, right? It returns me, so when I have a request A, the thing I took out of the slides because it made them a little harder is before you hit that, after you go into that routing to service B, your request is transformed to a vector of requests. And they're all sent out on independent coroutines. So in other words, this is all just fanned out. If I have 100 requests, it's send out. These can go to all different services, and I want to know when the whole thing is satisfied coming back. All right. So what does that look like graphically? This is what it looks like. right? So what happens is a request A comes in, and if it's going to service A, well, this was the original plan, just gets passed through. And that's why in the service on the other side, it just sent back a single response with the vector of all the information inside of it. So the wait was going on outside under our control. And I happen to know it was more of a synchronous operation that they had going on there. One of the reasons to get rid of it. All right. But when I went through the other service, what happened is if request A had a bundle of requests in it, it was fanned out to a bunch of request B. This, remember, is a bunch of futures I'm getting back. So I would have a vector of futures come back. Now, we actually made an optimization where I could say, listen, if I've got a bundle of futures and they're all not satisfied, if one throws an exception, throw the exception early, no, wait for the other stuff to come back. Right? So you can do optimizations like this, but it's not that interesting as I'd say. What's there anything else to say about this? Yeah. So like I say, we've done what I will call some of the simple base cases. But in the actual system I had to go and do, there was a whole bunch of batching stuff that was going on. And again, it was surprisingly easy to drop my proxy in because I did not change the semantics. The only difference with these batch processing handlers is they rotated through all the responses underneath. So there was no overall, so when you get this vector back, there's no overall something in here is bad. You had to scan through them, right? And all I did in this case is where we had to get all responses, right? Similar to what you've seen. And that just returned a vector of these things. Any questions? All right. So we're coming close to the end of the talk. I told you I paced it for about an hour. I found I came along a different path because I had a different viewpoint of where I was looking to go. I wasn't looking just to get this new service up and running and saying, I'll figure out when I come to decommission it. And if you think about the decommissioning that would be required on this, you could do two things. One is just delete the service A member and change the send to just go the one path. Right, and say someone comes along in the future, I can just plug another one in. Or you can say I want to remove that abstraction entirely. And you're only removing it in the one spot. You're not having to go to hundreds of files and mess with them or figure out where people have made incongruent changes in the handlers. Right, so the decommissioning becomes simple. So what is the point of what I'm trying to get to here? Is that you channel good practices via wrapper with constraints. You can call the wrapper whatever you want, but it's a way of saying that, listen, I have a really well-designed API that someone's given me, but it's too wide, and it's too gnarly, and I want to make it simpler. It has bad ergonomics. We wrap it in, well, we put it in a wrapper. In our case, we made sure we had move-only data. We got away from callbacks. We had future promise semantics. We had proper ownership. And it gave me that layer of abstraction to absorb these, what would have otherwise been a punishing change. Because I looked at a set of change requirements, I didn't just go out there and say, what's the shortest line between A and B? All right. If you remember the original requirements, what we said is, listen, I'm going to localize the meaningful changes. And the meaningful changes were in the service proxy, right? They were in the error handling, where I just put a new check response. And what was the third place I put it? I forget. In main, I just created an instance of these things, right? Because we had coroutines, we were able to guarantee that if we created these things at the beginning, we made sure all the coroutines are shut down, and then we hit the destructor. And that just made it that for stuff we did need to copy, like handlers, it was very lightweight. So what's the end game of all this? That's like the little bits and pieces. The end game, what you need to take away with this is you need to have a better delivery of change if you're in a system that is fault intolerant, where doing the wrong thing can affect your reputation, open you for lawsuits, all kinds of bad things, right? And that happens by mitigating production risk. Now, as engineers, I don't know, I get the feeling, my opinion, as engineers, we're like, somewhat get bedazzled about, I can do this really complicated thing and bet you can't figure out what it is, right? You sit down and you're like, oh man, you're so good at this thing. The syntax, what I call the syntax of the language, and making it do unusual things, surprising things. But for production, what you want is a system that's easily readable, comprehensible, and the errors are not that hard to spot. And what I can tell you is in this particular system, because it was coroutines, everything was parallel. Object lifetimes would have been a nightmare if you were just allowed to go in there willy-nilly, right? So anything that you were using a reference from is something that was either just used locally inside the coroutine that would never spawn outside it, or it's something that's created at main and does not get destructed until you leave main. All right. And this made the problem tractable. And again, there is, in our industry, we're littered with problems where we say, listen, if we try and rewrite a system, and I've seen it happen a couple of times, you try and rewrite a system, you fail. Try and rewrite again, because your idea, and there's another talk I'm giving, by the way, on Thursday, which is about redesigning legacy systems, which goes into this, right? You have too simple a concept in your head of what goes on in the real world. Your mental model of what goes on in the real world does not hold up to reality most of the times. And this is how you deal with the real world in a way that does not mess and bend your system. So, if anyone wants to go and check out what I've done, or as someone in the audience says, move to Sphinx, or move to, what did you say? Concepts and something else?
I talked about a generic lambda.
A generic lambda. I would love to see these things, right? If you can go away, figure that out on Godbolt, just change my system in Godbolt and show me it. I'm really interested to see what are the alternate ways of doing things that work in this particular scenario. All right. And like I said, the scenario we did was just a single request response, right? But in reality, I have vectors of these things going on. And that was one of the reasons for the move decision. Because if anyone's not aware, unless you have a strong guarantee with moving vectors, and I've seen talks and stuff to be where they put a simple object with the copy constructor, I am copying the move, I am moving, and you try and do stuff and you're shocked that you're not moving. Right, so this way, when we wrapped it in the abstraction, we took hold of that. And people say, oh, you're scared of people using C++, or, hey, you know, programmers know this stuff. It's like, I want to reduce the computational load on the programmers, so they don't have to think about this. And if they slip up, and I've slipped up with code, I didn't know copies were remade, the compiler tells me, hey. And I really have to work hard to get a copy, which I'm fine with too. If you really need it, get it. All right. And remember, we also took down the idea of blocking calls. All right. Because if you leave blocking calls in there, I guarantee you someone's going to think that's the easy way out. The asynchronous array is a little hard. It's always harder to do something asynchronously. And what they do is they say, look, and I sneak that in, get my buddies to do the PR. I come along a little while later and like, who the hell put synchronous behavior into my system? But my benchmarks start having a problem. That is the end of the talk. I see I have 29 minutes left to go. Have we any questions? Yes.
When we discussed the error due to the direct access of the response pointer data member, that was a unique pointer, and we presented an initial solution of overloading the dereference operator and arrow operator, and we were disgusted. Would we have been as disgusted if the language had support for, I don't remember what it's called, but like I think in C#, you can have data member access syntax that actually calls a member function instead. Properties. Would we not have been disgusted if that was idiomatic for a language?
Right, so what language were you in there with properties?
C#.
C#, all right. I did a little bit of C#, but it's so long ago I forget. So Could you say that again? Because that was quite a bit of discussion between you two.
C# lets data member access syntax invoke a member function.
Oh, okay. All right. So the language sort of gives you that help as part of its basic framework, right? So the question is, if you have language support where any member variable you go to grab, there's already a sort of a default getter, I guess, and setter, yeah? That would have helped me here, right? Because as you've seen, human error, I came up and said, listen, I have a response carrier. Let me see if I can find it here. All right. Is this it? Nope. Is this it? Yes. All right. So this here was where I had to go through a lot of very ugly coding to keep the contract. It just shows I made a poor decision, right? And actually, I didn't make that decision. It was there before I got there, right? But this is, you have to live with what you have. And this was what I would have had to do to say, dereference me the unique pointer that's inside of here. And yes, if the language supported, I'll name this response, let's say, and then I'll have a get response or something. I think that's what you're saying in C#. Then yeah, I wouldn't have had to make the error and learn from it, right? And I had to do this, right? But I took away from this that don't have direct member access unless you have some real reason backed by performance data to say this is what we need. What I found in the system I was working in is we had optimizations that didn't give you optimization, but they certainly made the code less readable. And I always say, come back with some graph or some results that show me, not like, well, common sense would dictate. Common sense is not as common as you might think, and sometimes you have something that's not intuitive.
But following on Ezra's question, I'm not sure that the property would help here because you return a different type. So a property allows you to add validation, but by default it would return the type of the actual data member. And here the idea is to return something else.
So the comment was, properties wouldn't actually help you here because this get response actually does not return the member. It returns a sort of mutation, not a mutation, but a transformation of that, right? So I'm going to say, what have you got buried inside you? Right. The other thing we didn't do is, like I say, we could have gone down the road of saying, hey, let me make this move only by deleting, looking up the rule of 5, rule of 3, the rule of 1, and probably getting it wrong if I'm in a hurry. And then saying, all right, now the memory management, let me take care of that. And this has been suggested, and like I say, when I was doing earlier versions of this talk, why don't we just take the memory pointer from the COM system, manage that ourselves, delete the copy constructors, because historically we have a terrible track record of doing that, right? We didn't get a unique pointer just because someone liked the name. We got a unique pointer and shared pointer because it's something we do wrong a lot. So use the tools that are there, don't roll your own. Same with callbacks, all right? Callbacks, gnarly, we've decided to go to future promise. Right, that's kind of the direction the language is going in. Is that the right place to go or not? We can debate that, right? The things I like about it, things I'm not that happy about, but it's certainly understandable. Anyone who knows modern C++, or from 11 onwards, will understand what these are. All right. And other things that happened during this, by the way, is I brought the code base up to C++ 17 because they started this thing with C++ 11. And I'm somewhat chagrined to say I got rid of all the boost stuff, like boost variant, boost this and boost that, and made it with the standard versions of it. But for the most part, I think the calling semantics were the same. So I always say if you're making a change in a code base that doesn't change the meaning, right, or how stuff is called, it's probably a safe-ish change. Because and I say safe-ish, it's safer than just saying, let me rearrange hundreds of files and see how it goes, right? That's usually recipe for problems. Anything else? All right, so I'm here all week. If you need to ask me anything or you want to sort of take me down in some really technical chat later, just come find me, bring a God bolt, and bring your terminal with a God bolt on it so I can see what you're talking about. Other than that, thank you for coming.